Let us now find out as to what is the linear size of central maximum. Seen earlier that in case of diffraction, the graph of intensity versus path difference, something this kind, where the central maximum has the highest intensity and also maximum thickness. So here we need to find out what would be its thickness. As shown here, we've drawn a graph of intensity and its distance. It's the y-axis here would show the path difference, and x-axis shows the intensity. This graph, let us call the distance between first minimum and interest y. Thus, if you look at the graph of intensity versus diffraction, what we get, we need to define what this width was. But this corresponds to the first dark band. All this as some w with this w of the central bright band. This corresponds to the first dark band shown here at the angle which that makes be called as theta. Now we need to find the total distance. So from here, the width of the central maximum would be 2 times y, where y is the distance between the first minimum to the center of the central band. Now we know that condition for path difference for dark band was d of sine theta n is equal to n lambda. Now here we'll be focusing, or we're drawing a line to the central of the minimum, the first minimum. So here n becomes equal to 1. So what we get is d sine theta is equal to just lambda. For the sake of simplicity, I'll just write this as d sine theta is equal to what we get. This is the condition for the first dark band. Now, since or if the angle theta is small, then we know that for small angles sine theta is almost equal to theta, and tan theta is also almost equal to theta itself. So for small angles, you can say sine theta is same as theta itself. Therefore, you can rewrite this as saying that d into theta, but small angles theta is same as tan theta. D into tan theta is equal to lambda. Let capital D be the distance between slit and the screen. So tan theta from this triangle would be d into will be y by capital D, that's it. Or y from here would be lambda capital D by small d. This is what is y. But we need to find the width of central maximum, and that width of central maximum is equal to 2 times y. Therefore w is equal to 2 times d by, this is the width of the maximum. And also the angular width is the angle made be 2 theta, because we need to find the angle spread of the central maximum. That will be from here to here, should be theta here also, that becomes 2 theta, that is equal to 2 times d, because theta same as tan theta be a by d. So angular width called some capital theta, just call as capital theta. Put a symbol like this, capital theta with a line here, and this is equal to 2 lambda by c. This is the width of, or angle width of the central maximum.